so we know when the ads are on and when the ads are not.
Well, I mean, we'll still just talk through it like normal.
How many people do you usually have watching on your stream?
Oh, it's ranged from a handful to a few dozen.
That's Raymond! Raymond!
He's a bit of an eccentric, as you can see.
Hey, that's good for brand identity.
Exactly.
Well, a double-edged sword. As long as you don't, as long as he doesn't start saying some horrendous shit, I mean, we're good.
But
Mhm.
it's your turn.
Oh, we're streaming. That's okay.
No, sir.
We're just getting ready to do a live stream. This is Lorenzo, damn near a full-bred mathematician. This is Ethan. Also a very smart fellow, or this is not a fart smeller, but a smart feller. And he's helping us position ourselves. What program are you running on? What degree are you working on? You got one and you're working on another one, right?
I'm working on one and then I'm doing another.
That's what I just meant. I don't know this whole backstory.
There you go.
But we're doing Tim and
got
Lorenzo dance.
new boards here? Why do they look shiny?
Because they're chalkboards.
No. But like anyway.
Someone cleaned them.
Okay, and like high quality chalk. Look, anyway, it looks
Blue.
Looks great, yeah.
I just want to say,
Yeah, cool. As usually, I see you sometimes deep in thought, and
Yeah.
so it's funny to be kind of like jolted out of my.
yeah, I know you were. I was taking a chance on that one. See you later, man.
All right.
Why, yes, indeed, young folks. Welcome to another edition of T&L Talk Statistics. And I'm sorry, you're probably wondering, what the hell just happened there? Well, I'm a social creature, and I met a friend of mine who is a tad more higher up on the legendary totem pole of academia than I am. And I just had to say hi and show him what we're doing here, because this is kind of unusual in that it's entirely ad hoc, it's entirely ad lib. Lorenzo, get your butt in here. I don't want people think I'm talking to an imaginary Lorenzo here.
I'm not, I don't exist.
And we got Ethan here too now. We're going to introduce him in a minute. I know he doesn't expect that, but we're going to introduce him anyway. So as we've done here in the last couple of streams over the last 2 weeks, we're going to continue on with our discussion of the chi-square tests for homogeneity independence today. And you're going to hear it called cheese square. This is going to be an ongoing joke between Lorenzo and myself in that we're trying
Pronunciation is no joke.
Well, it certainly is when you're Italian.
Hey. Them's fighting word.
They are. But you see, I'm going with the Greek. He's going with the Italian. It's like, if you ever played Fallout, New Vegas, you have the reincarnation, if you will, of Caesar's Legion. But it's Kaiser. Us Anglos, we see the CAE and we say, oh, it's Caesar, right? But of course, it's Kaiser.
Kaiser in the Latin.
Cesare.
Cesare in Italian, yeah.
Did I get the accent right?
Yep.
Cesare.
Perfect.
Okay. Giulio Cesare. Did I get that right?
Yes.
Okay. So we're never going to settle this. My point is, it depends on how you're coming at it. But that's a lot like math. What is the utility of mathematics? Well, it depends on what you're doing, right? It depends on how you're coming at this thing. And as you have probably picked up over time, we take a pretty lowbrow, low-key, I shouldn't say lowbrow.
It's not lowbrow.
We're being true to math.
This is like one brow up, one brow down.
That's right. Well, that's indicative of a stroke, you know that.
Okay, well, there you go.
FAST, the face, speech.
I think you missed an A in there.
Well, no, I can't remember exactly the A, but the point is, if you got the symptoms of one eyebrow up, one eyebrow down, you can't talk, and you're wobbling, it's probably time to go to the hospital.
Oh, I see.
Hey, you learn that on House.
Oh, there you go.
Well, actually, my wife learned that on House, so I make no secret of this, but at the very start of the COVID epidemic, I had my House fast moment, because this is prior to the vaccines. I was one of those lucky people that got one of those COVID-related clots to the brain. You don't need to move away. I'm not going to explode.
That was coincidence.
Okay, just check it. I'm not going to be close to him when his veins pop. It was an artery, actually. So, anyway, the point is you can learn things on TV or
If it's smart TV, if it's good
That's
TV,
right,
yeah.
that's right, yeah.
And House is a very smart series.
Very much so.
Yeah, it's great.
Yeah, it puts shines a different light on a profession that in many ways is similar to mathematics in that it's extremely broad.
Problem solving.
That's
Lots
right.
of
And
hunting
in
and
context
seeking.
of a discussion we had just prior to going on live with the stream, mathematics is such a broad discipline. If you think of all the different applications of math and the things you can learn in math, no one has the keys to the entire toolbox. You can go over. Well, I'm going to point that way. That's meaningless to our viewers, but
The department's that way.
but I can go talk to the smartest person, arbitrarily chosen smartest person, randomly and independently and
Oh, there
identically
you go.
distributed smartest
Yeah.
person in the math department. They don't have keys to the entire toolbox. And we don't expect you to have keys to the entire toolbox. What we want you to come out of these streams with is an appreciation for things that you can do with keys to the toolbox. And that brings us to the chi-square test for independence. Whoops. Ethan, you got a moment?
Yes.
Just stick your face on it.
Come on up.
So we have been
The newest.
referencing this as the triumvirate of, well, various adjectives. Well, now we got to come up with a new word because there's 4. Ethan is helping us out with figuring out how things work. Hi, Ethan.
Oh, there.
This is your first time on camera?
Maybe.
Maybe. Well, you did very well. I don't want to put you on the spot.
Fair.
You can come on the spot later.
All right. Sounds good.
Okay. Peace. Anyway, my point is, I have many points.
Mm-hmm.
My point is, here's something you can do with statistics. And the application we're doing here today is populations and how it relates in biology and things. So we're going to continue on with the discussion of winged turtle shells,
That's correct.
a la Mario.
That's right. So, not Koopas, no copyright infringement here. I mean, unless
Unless you want it
Nintendo
to
wants
be.
to make some noise
But
and
you know what?
give us the free
There
advertising.
is the fair use policy of copyright laws.
Ah.
So it's not strictly sticking it to Nintendo here or stealing from it. Yeah, we're using their ideas, but at the end of the day,
They're using nature's ideas. They took a turtle and made it into a Koopa. And hello, Mean Machine Rex. Good to
oh,
see
cool,
you.
right on.
Yeah.
Welcome, welcome. You're probably wondering what took so long to get this thing running today. It's the summertime, so we've had our moments.
It's a lax
yeah.
schedule.
Well,
It's not a
I'm-
schedule, it's a schedule during the summer.
Like chi-square?
Cheese squared, yes.
Chi?
So,
Chi?
anyways, we started
Anyway,
off with...
why don't you take
Yeah.
over for now?
Okay.
Chi-square, there's a new one. Chi-square test for independence, and you can explain the setup, and I'm gonna just move over here and grab my blue chalk,
Yeah.
which is synonymous to a blue shell, but you have green, so.
We're not doing blue shells in this. No. We started off with a test for goodness of fit, the chi-squared goodness of fit test,
Yep,
to determine Hardy-Weinberg equilibrium of allele distribution.
Yes, that's right.
Yeah, the alleles. That's what we did. Yeah, I'm trying to remember what we did.
That's fine. And just for someone who's just joining us too, or someone who didn't previously view, the word homogeneity is a $5 way of saying,
Oh, that was the next one we did, right?
Yeah.
Everything evenly distributed, right?
Right.
Across multiple populations or geographic locations.
That's
so
right.
that was the second thing that we did. Now, this third one that we're going to do ties that all together. We're talking about independence now between 2 types of genes. The first type of gene being the one we discussed first, the shell color. The second type of gene was the presence of wings. The winged Koopas. I mean turtles, of course. Genetics, yeah. Oh, we'll be doing, so Mean Machine Rex, we'll be doing lots of genetics here because I love biology.
and that's his specialty, and I'm not gonna interject
Well,
beyond
I don't have
saying silly
specialty.
things.
But we are in the process of working on tutorial documents for the statistics with genetics and other concepts in biology. So population ecology, population genetics, all of that. And that'll be posted on our Discord. We almost forgot to plug the Discord and the
Yeah,
materials.
we'll talk about the Discord tour a little bit later on, because we're on a roll here. I don't wanna hold you up, but the point is,
Are we rolling?
we better be. I'll check. No, we
No,
are.
we're-
We can
of
see
course,
right there.
yeah, it's
My
bad
point
joke.
is, Yes, we're goofing around and having fun.
Ah.
But if you want just the facts, ma'am,
That's the document?
then it'll be laid out. There'll be PDFs, just how to do it. Download them.
So yes, we will. We would definitely appreciate your being our community TA for biology-related material on the Discord. Are you on our Discord, Mean Machine Rex? I think we've posted the link a few times.
Yes,
I
that's
don't.
right.
We don't have.
Well, you know what? All you got to do is just go to Discord and look for the Doodler Wizard.
Oh yeah, there you go.
That's the easiest way to do it. And Adrian is currently doing adulting things. But he's also got some research going on too. Now, I'm not going to spill any beans on that because
yeah,
that
we pushed
would be
him down a
wrong.
rabbit hole, and now there he is.
We're talking about sewers here.
The sewer hole.
He's down the manhole.
All right, so Sensation Black, our good friend, is also commenting. If your wallet hits the floor, who will reach it first, bacteria or cash it? What is that one?
I don't have my glasses on. If your wallet hits the floor,
Yeah,
Who
who will
will-
reach it first, bacteria or cash it? Am I?
Kadget! Asa.
Cash it. Like
Kadget
Kadget?
has wares if you has coin.
I don't.
Skyrim.
Was that?
Skyrim.
You
I'm
coach
old-
there, like I've never
old
played the
school
game and I
games.
know that one.
I can go at length
You've
on.
never taken an arrow to the knee? I mean, I see you limp. I mean, my limp is from playing with motorcycles when I was
Morrowind?
young. Yeah, if
I can go
Kadget
on
has wares if
at
you has
length
coin.
on the first 14 Final Fantasies and their spin-offs, okay? But there are some things I have not played.
You know, there's a word for that. It's called fetish. You just like hot chicks in miniskirts and high heels running around slaying abominations.
Are you talking about like Buffy the Vampire Slayer? Because
No,
I'm also
talking
big
about
on that
Final
one
Fantasy,
too.
Because my sons have played Final Fantasy, and I'm watching this hot chick in a cocktail dress running around in shoes that are not sensible at all.
Was that Final Fantasy 13? I want to say.
I don't know which one it was. I basically watched it happen, and I'm going, how do you do that?
Okay, I did play a little bit. So Sensation Black. I did play a little bit of Oblivion. That was Elder Scrolls 3. I want to say. Is that correct?
Ooh, on the topic of Elder Scrolls and Bethesda, you know, in the Fallout series, if you look at the power poles in post-apocalyptic America, now maybe you don't know this because urban life, all power lines are underground, but if you're up in the middle of nowhere, or you go back in time, all the power lines were above ground on wooden poles. If you
Lightning
look
maintenance.
at them, every pole would have its own serial number. That way you know where to do repairs, right? It's always TES and then some numbers, which is an Easter egg for the Elder Scrolls.
Interesting.
Very.
Okay. Yes. So fun fact with this now in the real world.
Yeah.
If you ever find yourself in Saskatchewan for some reason, you'll notice that the
And there's
power
plenty
lines.
of poles there.
Yeah, the power lines have to be made so short because everything's so flat and they attract lightning.
Well, actually, and you know the thing is too, if you've ever wanted to see a real world example of disappearing at infinity,
Oh,
because growing up, you'd have power poles and you'd have telephone poles. And sometimes they're on separate sides of the dirt road you're on, and they just disappear at infinity.
yeah, that's eerie. The eeriest place I've
It
ever been
shapes
to.
your character when you grow up that way.
Yeah, sure.
And we're not defining that as a good or a bad thing. I'm just saying it is.
It's like nature pounding a block of clay, and there you got a Sasquatch.
Especially the use of the word pounding.
All right. So let's continue
All right.
on with the.
See, that's what I don't guarantee that we're going to go straight to anything when we start here. I haven't done any Monty Python stuff, but I was thinking about the Philosopher's Song this morning.
Step 0.
All right, I'll stop.
Assumptions. So these, I'm not going to go through them here. They'll be posted on the document, on the Discord. Check them. But one thing I will mention is that part of these assumptions for the chi-square test is that you need to have a 5-count minimum on your expected, not the observed,
Yeah.
obviously, the expected cells. Otherwise, the test is invalid. Now, some sources will say at most 20% of your expected cells can be less than 5, but that varies. Weiss, I use Weiss a lot. probably the bulk of everything I do is in Weiss. And Weiss will say at most 20% have to be, or 20% can be less than 5.
Now, what do you do when you have that problem? So this is contextual, of course, depends on what the problem is you're working on. But let's say we were talking about beer, wine, and hard liquor, and male and female. There's your typical 2x3 table. Let's say we had a beer was only less than 5. I know it's highly unlikely.
Well,
but
we could just do the.
But the thing is, beer has more in common with wine than it has in common with hard liquor, and with the exception of Boilermakers. You know what a boiler?
Gross.
Yeah. Well, actually, you know what? I don't mind a Boilermaker.
Like after a night of drinking, maybe when you can't taste
Well, that's the
anything
hair of the
anywhere.
dog that bit you the night before. But
Exactly.
the point is, if you have a category that's too sparsely populated, put the two that make sense, that make the most sense together, and you can usually eliminate
Oh,
that
there you
problem.
go.
But of course, everything is contextual here. Over to you.
Yeah, but that's a way to massage statistics, to lie with statistics. I don't know.
Well, again, it's contextual.
Of course.
And, you know, it's a judgment call. And a lot of things in statistics are judgment calls.
And semantics. And
That's right.
we'll do an entire series on lying with statistics. So just to answer your question, yes, the long hair man is Lorenzo. I'm usually behind the microphone and the camera when Adrian's on. But
Yeah.
yes,
Well, you know
that's
what?
me.
It never occurred to me, and that's because we don't do any video editing. But we could put little video tags, you know, say, Lorenzo,
Yeah.
big guy, never shuts up, Tim. But, you know, at the end of the day, I'm hoping that we're going to build an audience. You'll get to know who we are. It's sort of like Abbott and Costello from the 50s. Now I'm having trouble going now. Which one was the short one and which one was the tall one? Now I have to think about that. Carry
Yeah,
on.
I don't remember. All right, so step 1. 20 minutes later, step 1. We have our H, null, which is independent, or no association between the.
Very good actually, because oftentimes on exams and questions, they're not going to blatantly use the word independence. They'll use words that are synonymous with that. So oftentimes your instructor will say, is there an association between this and that? And they're saying independence or dependence. And there's probably a half a dozen different ways you can phrase that. But it is a thing. And a discussion that we were having prior to the stream too was over COVID. I noticed a lot of my students, because I did so much math on COVID, you know, calculus, stats, and linear algebra.
Ooh, on that note, just to start to cut in, but we did a playlist during COVID with Adrian, because that's what he did, that SIR model of epidemiology. That's what he did for his PhD.
Yeah.
Go watch it, please.
Oh,
Spent
yeah,
a lot of time editing.
we
those.
should point out too that if you look at our YouTube channel, I mean, there's an entire undergrad degree in mathematics sitting there just waiting for you to view it. It's a huge, like the
linear
stuff.
algebra, multivariable calculus,
Oh, yeah.
some mathematical modeling. Yeah.
I'm just filling in the statistics that we're missing.
There you go.
And I would like to do some other stuff as well too, but you know, that's going to be largely reinventing the wheel. But I was going to say that I noticed that students often had a hard time of interpreting technical words, and we should have a discussion about this
Yes.
sometime, about identifying what the root word is in some word that you don't understand, and then extrapolating from there. So that's something that's coming up, because what triggered my thoughts on it were the room we're using here has a window. I noticed one of the people that I used to work with in that department who actually teaches language skills made me recall a discussion that her and I had about find the root word, which will then help you find the meaning of the word you're stuck with. And I know it's got nothing to do with statistics, and this is, I'd never shut up. Are you done writing? Yes, you are. Go ahead.
Oh, I finished a while ago. So just a little bit more for the context here. What does independence mean when we're talking about two genes? That means that they'll obey the law of independence. So in front of the camera now I'm spacing on the
That's okay.
terminology.
Yeah.
Basically, are the genes on the same chromosome will they assort independently when gametes are formed, or are they close enough that there will be linkage with the genes? So alleles will tend to end up together. Certain alleles will tend to end up together. So the allele for orange shell, or red shell, sorry, and wings, they might end up together if there's a linkage. That's what we're testing here.
And this is really interesting to me because I've spent over half of my life has been involved with mathematics. I know diddly about genetics. So when Lorenzo starts talking about genetics, I have to tune in on that because here's my opportunity to pick up something that ties mathematics to another application that I know next to nothing about. And that's how you learn. Don't let anybody tell you that, once you choose your profession or your
That's it.
your
That's
path
all.
through academia, university, college, wherever. Sorry, I'm not trying to sound like an academic, but the buzzword around this campus lately has been intersectionality. How does your discipline work with and benefit from another discipline? And that's the way to success in the future, because strictly isolated fields of research now, I think, are
They don't
really
exist
a dead
anymore.
paradigm. Anyway, I'm another discussion for another time. Carry on.
So turtles with wings. So when we came up with this example that we've been following through, this situation, my mind instantly went to Mario and Koopa shells. So
Well, I went to
Koopas with
Teenage
wings,
Mutant Ninja Turtles, but that
Yeah.
just shows the difference in age here, that's all.
I suppose. When did TMNT? Was that before Mario? Or was that
Just let me have this one, okay?
Okay, sure. All right. Anyways, let's move on to step 3, which is.
I will do that. I will be your board man while you do the writing.
That's all right. That's all right. That's all
And I
right.
wanted to use the dusty thing.
Got to breathe in that
Since
shot
I
of
got my
dust.
coffee.
Yes, drink your coffee.
Sit over there, shut up and drink your coffee.
There's an E
You
there.
learn how to spell.
Okay, I'm still getting used to writing with chalk. So step 3 is calculating our test statistic, which is, this is the formula for the test statistic.
Ah, good old chi-square.
Chi-squared.
But what's that?
This is sigma. So
What does this mean?
add together all of the.
And what's missing?
In stats, we wave a hand at that. Yes. In math, that does bother me. But you're adding, so we could say like add together I, which is the observations, and then that would be.
And I'm not trying to be the proverbial dick here. It's been my experience, well, a lot of folks just coming into mathematics, we have to remember our audience, indexing variables are completely alien to them.
Oh yeah.
So sometimes it doesn't hurt to take a quick moment to explain an indexing variable.
Again, we kind of wave a hand at this because in some textbooks, I promote Weiss, but they write it like this, and it drives me bonkers.
Yeah.
Like, what the hell am I supposed to do with that?
Well, the problem with a lot of textbooks
So if they get away with that, I can get away without indexing.
is ambiguity leads to confusion. And you can guarantee that's going to cost you 2 or 3% off your final grade. We're trying to eliminate that.
Exactly, because that's
So,
enough to
that's
bump
right.
you up from.
That's right. So an indexing variable, I, J, K, whatever, the typical letters, says, well, sometimes if you look at my 17 video series for Introduction to Statistics, I do take a moment to explain indexing variables on
Yes,
there.
please
Go ahead
plug
and have a
your,
look at
plug the
Yeah.
playlist because that is fantastic.
Well,
This will
and
make
the
so
thing
much
is,
more sense if you watch that
It's
playlist.
only 17 videos because I tailored it for your typical summer school session that's 6 weeks long instead of
Yeah.
16 weeks long. Everything's right there. So I cut out all the crap. And here's how
Are
we
you
do it.
saying that typical semester classes are full of extraneous information that could easily be removed?
Well, here's a comment, and this is right off the top of my head. I haven't thought about this until just now. Having many examples in class doesn't necessarily mean they're useful examples.
There you go.
So repetition is good, but repetition with substantial variation is better. And it doesn't hurt to spend some time to simply explain what does these little subscripts mean. And even the word subscript and superscript, I've encountered
You know
students
what?
who aren't entirely clear on that.
Yeah, that just this past semester, I had to explain a subscript. Yep, good
And
call.
the difference
I
we're
will
talking
do that from
about-
now on.
Here's an X. So if there's a letter here on the upper right shoulder, that's a power, that's math. But if there's a number down here, that's an index variable. Says this is the third X in a series of X's.
That's correct, yeah.
Yeah.
The character up here could also be referred to as a superscript. That's a thing as
Bazinga.
well, yeah.
Okay.
So good. Now, we didn't actually prepare any of these numbers, so let's say that we had a table with values. It'll look something like this.
Mhm.
We'll have two of these. One will be the observed, the other ones will be the
Expected.
Expected, thank you. So here will be the gene, or I guess we'll discuss phenotype, because that's what we're actually counting. So here will be the green shells, the red shells, and then the heterozygotes will be the orange shells. And
Do I need my calculator to crunch numbers for you?
no, we're just gonna make this up.
Okay, yeah, because if you want me to, you see, I'm not against technology. You just keep writing, put some numbers in there so you can talk about it. I'll do a quick blurb.
Well, number.
Okay, he's gonna do it that way. Calculators are fine. I know a lot of math classes know calcs.
Oh, yeah,
but,
this is
We're
stats,
using tools.
uses
here. We're using
whatever,
tools.
yeah.
Go ahead.
So, okay, we'll have the observed, so we counted, so many green shells with wings, so many green shells without wings, and then same thing with oranges and reds, and then we have the expected, and the formula for expected is the row.
The expected formula, I'll write it down. So
Have at
for
it.
expected count on an n-way table, so I'm using a $5 phrase, n-way, more than one row, more than a couple of columns, so like a 2x3 or a 3x3 or whatever. So your expected counts, so I'm just going to write expected because I'm right at the edge of the board here. This will be the row total. So that means whatever this number is, that is your row total times your column total. And of course, the column total will be this number here, but as with all of these contingency tables, there's a grand total. So, and this is divided by the grand total. And this can be used to talk about proportionality as well, but that's for a video, another stream at another time. Anyway, carry on, sir.
Thank you, that was great, yes. So the thing with the chi squared is that it's tedious calculation intensive, because you have to do all those expected values, and then you have to do all of this business for the
Yeah.
test statistics, so you can end up with a lot. But it's
There's a
probably
shortcut.
this.
You want to do the shortcut?
You do, go ahead.
Okay.
You're
So-
on a roll.
Let's say this was added up to 30. So let's say the observed column total here was 30 observations, or the frequency was 30, total frequency, for observations. Well, this doesn't change for your expected. So let's say this was actually 15, but the expected count here was 20. Well, then I'm going to put that in brackets. So that means the expected count here must be 10 because the expecteds have to add to 30 as well. So you don't have to use this for everything. You just need to get started with it. And I've seen online homework where this is essentially what they're asking you to do. Fill out the table with expected counts.
Mhm.
Well, you can bash this formula if you want, or you can use your noggin, that's this thing,
Right.
and take a shortcut. And it works that way.
What's-
There's a couple of other shortcuts too.
That's for when you get really comfortable, though.
Yeah,
If you're
of
just
course.
starting out, stick to the formula. Be formulaic. Be
Yeah.
procedural, because those procedures were created for a reason, right?
That's right. And just to be complete,
That
if
also
there
has to
was
be-
observed 15 here, there would have to be observed 15 there.
Yeah, because that needs to.
But our expecteds might be 20 and 10, but they still have to add to the same number.
So, okay, good. Now that we have that, let's assume that we did all that together with the observed, and we ended up with a test statistic of chi squared equaling Let's say a rather large one of 17. We got 17 point
5.
point business.
You go 3 decimals.
There we go.
But this is an incomplete description. What's missing here?
Oh yes. The other thing that we need is the degrees of freedom
Yes.
with chi-squared always. The only thing you don't need chi-squared for is, or sorry, degrees of freedom, Z tables, right? I think everything else
That's right.
has
That's
degrees of freedom.
So you had a table. Okay, that's
3 by 2, right?
Yeah. Okay, so this one's a 4 by 2. We're going to use this one because I already put the mark on there.
4 by
So
2.
the formula for degrees of freedom is the number of rows minus 1 times the number of columns minus 1. And you can do it mathematically. And you would get, well, 2 rows minus 1 is 1, and 4 columns minus 1 is 3. 1 times 3 is 3. But if you have a table in front of you, you just stroke off one of these, and you get one of those, because I just said dangerous words there, and you have 1, 2, 3 degrees of freedom.
That is our gift to you, Internet, today. Take that and do with it what you will. Good. All right. So that's the
You write that, I'll write it down here. So,
2. So in this case, we have 2.
yep.
Good. That's the test statistic. Now, what do we do with that? We compare it to our critical value, which is our step 4.
I just had to do that.
Sometimes written like this, I guess. Crit.
I think for what we're doing, because of the chalkboard and everything, and the fact that this is a squared term, we'll probably just call it a crit or a critical value.
Yeah.
And that's pretty common. I think half the profs around here call it a critical value anyway. And in certain disciplines or certain applications of statistics, calling it T-crit or critical T or critical chi-squared is the language I actually use. And then you can compare it to the obtained test statistic. So in the case of a t-test, you'd have t obtained versus critical t
Yeah.
to make your decision.
And
So,
that's what
like-
we're doing. We're comparing two. They're the same thing,
Yeah.
but we need 2 different ones
Yeah.
to compare. One came from the data itself.
Yep.
Yeah, we'll get to that in one
Okay.
second. That's actually pretty interesting.
Yeah.
So the test statistic came from the data itself.
Yeah.
Came from what we observed. The critical value
Table lookup.
is table lookup, which means that came from our steps 1 and 2. It came from the question itself.
Yeah.
So it's obtained in a completely different manner, right?
Well,
The
and
theory.
it's analogous to the level of significance.
There you go, exactly, because you pick it based on your level
Do
of.
a quick sketch of the chi-square curve.
So the chi-square curve looks something like this.
Right, and it is dependent on the shape, the precise shape is dependent on the degrees of freedom. So this is typical for what we're doing.
So you have a chi-squared, what do I call it, crit?
Chi-crit,
Yeah, chi-squared crit, and that'll be here. This is determined by alpha.
Right.
The area under this curve, that's
on
alpha.
that right tail, that's right. So this line is alpha, and if our obtained test statistic is larger than this value, in other words, put a 0 over there for me, please, and an infinity out here, because it does go that way. If for the math people, this is approaches the x-axis asymptotically. I had to say that, okay? I have an obligation to say that.
It's
My math.
appreciated, yeah.
Okay, so any test statistic that lands out here, in other words, further away from 0, the larger the test statistic is, the more significant the result you obtained is. We're simply marking this as here's where we've arbitrarily decided that random sampling variability is no longer the explanatory reason for a result out here. So this is the reject the null region. Random sampling variability, also known as luck or chance, is responsible for this region.
Good. So
That's how I have my people remember it.
that's very good. And before we go continue with this
Yeah.
and actually do the comparison, let me read this out because this is interesting. So you're in a desert, walking along when you look down and see a tortoise. It's crawling towards you. You reach down and flip it over on its back, its belly baking in the hot sun, beating its legs, trying to turn itself over, but it can't. Not without your help. But you're not helping. Why is that? We have a riddle here. So this is Sensation Black.
Oh,
So-
welcome again, by the way.
Yes. So, all right. We'll wait for the answer on that one. I'm not.
I have to
Nothing's,
think about that.
Yeah, nothing's coming to mind.
I've not actually seen this pondering question before. I'm going to, while you're doing your schmoo here, it's my arbitrary word for I don't know
Everything?
what I'm talking about. You do your schmoo. I'm going to come around and read that again.
Good. Yes. All right. So, the goal here is to compare these two values. We looked this up, table lookup, right, based on how we set up the question. The critical value that we get for 2 degrees of freedom and an alpha of 0.5, 0.05, so 5% level of significance, is 5.991. So here's the crit, which is this value. The test statistic that we calculated is 17.015, which is way out here. So I'm gonna, not to scale, this is our test statistic. This is really awkward way of writing. We are deep within that rejection region, deep within it, which means we scrap that null hypothesis that said that there was no association or that there was independence, which means we accept, I use that word, yeah.
Yeah. No,
We don't accept, we settle on dependence, linkage in this case in terms of the genetics.
Well, probably, I'm a bit of a stickler for this, and I know in various
Please
disciplines
be a
and
stickler, yeah.
statistics, this is, entirely up to the, you're going to use the language your prof is going to be expecting to see. I'm not going to quibble
Yes.
on that.
Wise
But
words right there.
generally, though, what we either reject the null, or we fail to reject
Yeah.
the null. Because this is another discussion for another time. But remember, there's always a chance to be wrong in statistics. Type 1, type 2 error is what I'm talking about. And again, that's
We'll explain that next stream, actually.
That's right.
Yeah.
But the point is, if I say we have evidence to reject the null, we're saying that the preponderance of evidence, and I don't mean that in the judicial sense, but the preponderance of evidence say that there's probably a phenomenon driving this. Because notice I'm using weasel words here. The preponderance is likely or probably driving. We can always be wrong in statistics simply due to random sampling variability. So anytime you start to use language that suggests a certainty, you're treading on dangerous ground. Because at the end of the day, you cannot be certain.
Are you certain about that?
Yes, within a 2 percentage point margin of error.
Very good.
Hence the business of statistics.
So,
I'm a really big fan of, well, we'll talk about Nassim Taleb sometime and his thoughts on uncertainty in the application of statistics towards finance. But the point, it really comes down to everything in statistics has to address the margin of error.
mhm.
And it is not trivial. Over to you, man.
All right. Well, we'll just finish this off right
Yep.
now. So step 5 was making this comparison, making the decision based on this comparison, which, as we said, reject the null. So that means we come to the conclusion they're at the 5% significance level.
There we go. That's right.
The data provides sufficient evidence to support the idea that there's linkage between these two genes.
And here's the thing, the key thing that triggered my, there we go, is this. If I say alpha is 5%, 5% is 1 out of 20. So we're saying we're willing to tolerate a 1 time in 20 chance of a false positive. So the level of significance, besides several different interpretations, which all ultimately come down to the same thing, is saying we're confident enough with our research method, our sampling method, the general approach to the problem, that we can tolerate being wrong 1 time in 20. You can make this 1 in 100. You can make it 1 in 10. You can make it anything you want it to be. But you got to think about it carefully.
Yeah. With a critical value, with a test statistic this large, you could actually probably go down to
Oh, that's probably got 4 zeros before the first significant digit.
There
It's not
you
a
go.
zero, first non-zero digit.
There you go. So,
For instance, in
very
hardcore
short.
science, let's say you're a working physicist and you want to claim that you found something magnificently different than what's expected, you need 6 sigma of significance.
So to explain that,
6 standard deviations. So in the case of a normal distribution, you need to be at least 6 standard deviations away from the expected value to actually make a claim.
So at 3 significant,
Yeah, that's
3
99.
standard,
Yeah.
99% of everything is
Yeah.
right there.
Yeah.
More than 99%. So 6, way out here.
So this is somewhere around 1 chance in 10 million, maybe?
Something
I'd have to
like
look it up off the top of my head, but a 1 chance in 10 million of a false positive.
Awesome.
That's the
So-
pretty strict criteria.
I think that's good for today. Thank you,
Oh,
everyone.
are we gonna we don't have numbers today, do we?
No, we don't have numbers. That's
Oh,
why.
okay.
Yeah.
I was waiting for that.
This was completely ad hoc, just to finish off the trinity of
Right.
chi
Oh, and
squared.
then we should. There's my Mr. Ed impersonation. If you don't know who Mr. Ed is, go
He
to
was a
Wikipedia, you'll
horse.
find out. I'm old. I can make old people references, but I'm not a boomer. No boomer here. I'm a older Gen X.
So boomer.
Shut up. Pots upon you. The mathematics of the test for homogeneity and the mathematics for the test for independence are identical. The only thing that differs between the 2 tests is how you structure the null and alternative hypothesis.
The question itself, right?
That's right.
Yeah.
Everything else is exactly the same. And at the end of the day, if you're asking yourself, well, how do you categorize this? Chi-square is a multiple comparison technique. When you have a single sample, you have a single sample. You have a formula for that. If you have 2 samples, you got a formula for that. But as soon as you get to 3, 4, 5, 6 things you want to compare all in one omnibus test, and its frequency counts, this is what you're going to use. Analogous to this, we were talking about mean data then, would be analysis of variance, which I strongly suspect is where we're going next.
Indeed.
Now, I see you've gone over to the
I'm just-
technical aspect here, but I really wanted to do an ad hoc rendition of the Philosopher's Song from Monty
Which?
Python.
Oh.
Aristotle was a bugger for the bottle. Hobbes was fond of his dram. No, I'm having a brain fart here. Rene Descartes was a drunken fart. I think I drink, therefore I am. Baba Zinga.
There
Next
you go.
time. Okay,
All right.
I'll shut up.
Thank you, everyone. Signing off.